Hey everyone, welcome back. So in this episode, we're going to continue work on our nodes, specifically I think our primary nodes. But first, you'll notice I'm in our faults.kt file because one of you gave me a very useful comment. When I wrote this code, I did know that it was very stupid. I knew that this was the stupidest way to do it, but I couldn't find a better way. But this comment has helped to show me the light, so let's just delete these stupid variables. Because what I was doing before was I was relying on the fact that when you join an empty array to string, it will just be empty, which is why I was doing this. But what if we just join them if it isn't empty? Because that's going to do the exact same things. So we can say if warnings.size is greater than 0. You could also technically say warnings.like is empty. Is that a... That's an actual function. Not like a field. I don't know in terms of width. Warnings.size is greater than 0. Yeah, technically doing the size check by itself is shorter, so I'm just going to do that. And then we can just, if that condition's true, then we can just append to the string. It's like, just makes so much more sense. And now we have a few options here. We could do something like this so that we're saying the initial thing is empty, and then afterwards we put a new line, since we're always going to be doing this. You could also use like the name for whatever the name for that argument is, but in terms of line width, I'm just going to do exactly this. And of course, that's going to do exactly the same thing in a single line instead of making a variable for no reason. Similarly, we can do the exact same thing for the errors. It shouldn't really matter, but this is clearly just better code. And there we go. Now it's actually reasonable. Okay. I really appreciate when you guys give me feedback like that, because that's part of the benefit of doing a series like this for me, because I'm like actually developing my own language while I'm doing this, but then I'm also making episodes to show you guys, but then we can sort of refine the code together and make it better, which I think benefits all of us, so that's good. So thank you. Alrighty. So now we should be able to just go right back into our primary expressions. And on the right side, we have this monstrosity we'll slowly be making. On the left, well, since we're not running it, I guess I can just add all these lines in anyway. You're going to have some, errors. At least it's going to say that there's errors because these things won't exist yet, but that's okay. So the first one we have is if the parser.next, which is our it, if that thing is of token type num, then we make a number. If it's of token type string, then we can make a string literal, and we can do string literal.construct using the parser. We haven't made that class yet, but we will. Next, same thing for characters, token type char literal.construct. The reason I'm naming these things is because I think initially I called this number, but Kotlin has a number class, and like I don't want to mess around with like shadowing built-in names, so construct. So I'm just calling them literal because that tends to be a thing that you refer to. That's not a good sentence. There's usually like that's just how people refer to these things. So for example, if you have a variable x of 5, then x is a number, but 5 is a number literal, like it's an integer literal because it's literal. It's just there. It exists. It's not like in memory, it's just there. You could, if you're familiar with C++, it's like a right-hand value type of deal versus like a left-hand value, kind of. And then we can do token type.id for our identifier. And again, we can do id.construct. I don't know how I feel about this class name being called id, but I don't want to type out identifier every time. Maybe I should type out identifier, because then it's like the same width as everything else. it dot. And then, so now we have our numbers or strings or characters and our identifiers. But we also have some other things. For example, token.primary keys. We have all our primary keywords, which are going to be things like true, false, none. Maybe if you have a null in your language, you could put null here. If you're trying to make some weird JavaScript, you could have like an undefined. If you wanted, you could put like an infinity, like any sort of constant that you refer to with a keyword. You could make pi a keyword in your language if for some reason you wanted to, but you also don't have to. But we're going to, anytime we have any of these, we're going to make a primary key, construct keyword. Okay, and last but not least, we have our parentheses expressions. So if we have an open parentheses, then we should make a parent expression. And there we are. You'll notice that we're calling .construct with the parser on all of these, so technically there might be a way to store the class using reflection and then call .construct on it, but I'd rather not mess around with reflection again because it's kind of just a pain in Kotlin. And in other languages, it's like not even doable sometimes. So I'm just going to do it like this. So now we can actually go down and make these classes. Of course, we're going to have those errors for now, but that's okay. Not a big deal. I like to put 2 new lines between my classes that are in the same file, but that's obviously just a, style choice. You can style your code however you like. So we're going to have a char literal class. It's going to take in a token because it's a primary node. It just holds a single character token. And then we go through the whole rigmarole. We make our companion object, which will require a construct. And now this one's relatively easy, actually. We don't need to do this. It's just one thing, so we can just set it equal to an instance of this class where we say parser.expecting of token, can't spell, token type char. So that's all it takes to construct a character, because the character node is literally just like a container class for the character token. And that's it for now because we're not doing type verification yet. And you'll notice I haven't fully designed everything, but for now it's kind of as simple as we're just going to be storing the type. At least for primary nodes, that's kind of all it is. Alright, so here's the sort of huge one. And also I'm kind of really, some of these I'm making data classes and some of them I'm not. I'll be honest, I don't completely understand data classes, so I kind of just use them most of the time until it says I can't, and then I don't. But I don't particularly have good reasons to use it or to not use it. But I believe it gives us useful tools by default that we may or may not use. We probably won't use, to be honest. But it also makes the class uninheritable from. You can't extend this class. But anyway, we can make our string literal class, and so the way we've been doing strings so far, our lexer splits up strings into multiple tokens. That way, if you have a multi-line string, you have access to each source line that it's attached to. And that way, if you do string interpolation with like templates, then you have access to the nodes that should go in there. So this is why this is going to be a bit of a pain. But what we want is we just want to store all of the components in a list of fault components. And in this case, they don't need to be nullable because they're all going to exist. Let's see, did we actually... I think we did inherit faults already, or import, I mean. Component. Alright. We have to override the parts, which is actually really simple. We're just going to return the components. So this seems to work as far as I can tell. So what we're doing is, notice that parts is actually a list of fault components that are nullable. So what I'm thinking is, it's implicitly casting from a list of fault component to a list of fault components that are nullable. So we could sort of like store that as parts itself, but I think in terms of us, it's easier for us if we don't have to deal with them being null, but the node class still expects them to be nullable, so I think this is just sort of the best way to do this. We can make our companion object, which is a node companion object. And now we can actually begin making our ridiculous construct function. Okay, so the way we started this, right? What we've been doing so far is we have this abstract primary node, primary expression class, and when we try and construct it, it will just go through. So when we begin making a string, we know that there's a string token So the next parser.next is a string token. Then we try and make the string literal. So the first thing we have here is some string token. So we can say that that's just the starting one, and that's parser.expecting has, or expecting of, token.type.string. And of course, similarly to before, I'm choosing to use expecting of here, because even though we know for a fact it's there, just in case anybody ever tries to make a string literal some other way, because we might do that for some reason, then it's still going to guarantee that that token is a string. And then there's one simple condition here, right? This is the starting token simply because it's the first. So what happens if this token, this start, is the end of a string? Well, what that means is we've made our entire string. It's a single token, so it's going to be something like this, right? This is a single token of a string in our language. So this string token is going to both be the start and the end. So if we just do a check to see if it is the end, and that's true, that means we can just make it with this single token and call it a day. We don't have to actually do anything crazy. List of just containing that token. So that's the really easy condition. And if you're not doing strings all split up like I am, that's essentially all it would take to make a string token, or a string node, I mean. But because we're doing this, we're going to have to actually sort of go through this process. So now we want to make this mutable list of fault.components. And it should contain the start token. I'm calling it parts, even though it's kind of components. It's just, you know, a name. If you want to be consistent, you could call it components. And so now we have to do a loop. While the next token is the start of a string, or it is the next token is not the end of a string. So let me try and think about exactly where this comes from. So obviously, if the next one is the start of a string, that means we're going to have to actually like make a token with it. I'm trying to remember precisely. Let me read exactly what's going on the right, because if this is complicated for me, it's probably complicated for you, and I wrote this. So we can store if the next thing is a string, okay, and then next continues is it's a string, and it's not the start of a string. So because you can, suppose it's a multi-line string, then you could have the start of a string followed by middle pieces of strings, and then eventually an end of the string. Let me just type all this out, and hopefully by the end I'll have a good explanation. So next is string. That's pretty simple. We're just checking is token.type.string. And this reminds me of that video where they're talking about, I know, code aesthetics, I think. Their video about comments, where, like here, you might be tempted to put a comment to say exactly what this is, but really the ideal thing I should do, once I remember this, is I should just set this condition as a Boolean and give that Boolean a good name. And that name will essentially be the comment. Because like this line, for example, where I essentially do that, you totally understand what it's doing. The reason I'm storing this value is mostly just for line width more than anything else, but it does help readability as well. So next continues, meaning it continues an existing string. So maybe I could even make this better and say like next continues string. Means next is string, and not parser.next is string start. Oh, that's kind of too wide. So yeah, I'll just say next continues. So next continues means we're in the middle of a string and we're just continuing on. And if next continues, then we can just add this component because it's just in the middle of the string. But otherwise, if it's not, then what that means is we have to actually make some expression, and that because that means we use string interpolation in there. And I think I'm beginning to see where this condition's coming from. I think I'm overthinking this. So obviously if you're at the end of the string, then you should just end the string. So that's obvious where the right part comes from. But the left part, if parser.next is a string start, that means, okay, yeah, I totally see where this condition is coming from. If the left part is a string start, then that means we have something like this. And this token is going to be something like an S, followed by single quote, followed by another S, the whole string, followed by another S, ending quote. So for, oh, I got rid of it there. So this first one here, that's the start of this string, which we already took. But now, when we approach this while loop, parser.next is string start is true, because this is a separate expression that we have to actually have to parse it separately. So that's why the first part's there, and the second part's there to just say, and we're not at the end of the string. So maybe in the future I'll refactor this and give that a better name, but I also don't know if that's strictly necessary. It might be nice to do though. Okay, so otherwise, right, we're not continuing the string. We have some expression we have to make. And if that's another string, we can just make a new string node. But fundamentally, the most abstract thing we can do is, firstly, we can ignore any new lines, because what we did with our lexer is if you had something like this is valid, but it's still going to retain the new lines in there. So what we can do is we can just ignore any new lines if there are any. And then what we have to do is add an expression that we are constructing here. And then, of course, after we can also skip any new lines. And so that gives us our string templates, because now we just make the expression, just like anything else. And we made the tokens set up correctly, which means the expression will be set up correctly. And then at the end of all this, once we've reached a string end, then we can just add the string end by taking it. And we can return a string literal. And the cool thing is, val cannot be reassigned, because I misspelled this so it doesn't know its type. Okay. So this will just work recursively, because if you have a string in a string template, well, a string is an expression, and the expression node will just cascade all the way down to another string literal node, and then there you go, it will be nested. And then in the future, when we want to actually get the sort of like transpiled value of this string, we can just sort of go down the tree structure that we've created with our mutable list, which will eventually just be a list. So I hope that that makes sense. And again, as always, if you have questions, ask them. I'll try to reply to them. Well, I will, at least for the first like month or two. It's almost a guarantee I'll like see it and reply. But I can make no promises if you're watching this like 2 or 3 years after. Class, I call this identifier instead of ID. And this is, again, it's just another primary node, because it's just going to retain the identifier token. So it's going to be essentially exactly the same as our character. I guess one thing you could do is you could make the primary node have its own default constructor, and then you could have a property that's like, what should it take? But when it's one line, I don't really see the exact need for that. Parser type parser returns, well, it returns a node, but we don't actually have to specify that. Identifier parser dot expecting something that is of type token type ID for identifier. I misspelled identifier. Identifier. That happens so much. Okay, we only have, I think, these 2 more. Okay, primary keywords. Very similar. Primary node takes in the token. Constructing it is essentially the exact same thing, except we're going to be using token dot. We're going to be using has instead of. Node dot companion object. We override the construct parser of type parser, and it equals an instance of the primary keyword node parser dot expecting has something of a primary keyword. And then, of course, like I've mentioned before, if we just go in our token class and modify that list, then our nodes are automatically updated because we're referencing it. So if we want to add something else to it, we're good. Of course, that's only good for the parsing, but as you can see on the right side, for the verifying, where in my language I have 3 primary keywords, I have none to represent optional, like it doesn't exist, and I have true and false. So for type verification, which again we haven't gotten to yet, I have to notice, well, if it's none, then it could be any type, but it's an optional type. And if it's not, if it's true or false, then it's a Boolean type. We'll worry about that later, though. But that's sort of just to showcase, again, why we're making all these classes for these very simple things, just so we can sort of do that. Hypothetically, I have thought about this. You could make it more generic in the sense that you could make the verify functions for these things, and then you could just like make a generic node, and you could be like, well, this node is attached to this verify function, or to this function, right? So you could make the functions separate, and then attach them into a generic node. But to me, I don't really see that as being much different than this. It seems like it's this with extra steps, but I suppose that's an alternative. Okay, lastly, we have our parentheses expressions. Expression node. We need to override parts. And again, a parentheses expression, what is it? It's the left parentheses, the expression, and the right parentheses. If you want it to display out in your file, in your node tree, then you could store the left and right tokens as well for the parentheses. But to me, it's sort of implied when you have a parentheses expression of a node that those tokens exist. So I'm just going to store the expression, especially since the expression is the only useful thing for the rest of the process that we're doing. But you have the choice of what you store as parts of your nodes. I believe my code only works if you have at least one thing, although it might work if there's nothing, based on how I've done it, because I've got rid of all the null stuff. So I'm actually not sure. It might just print out the name, even if it has no components. Previously, it would just completely failed, so maybe that's an improvement. Okay, we need our companion object. Override fun construct. Parser type parser. Returning a node. And constructing this is very simple. Obviously, we want to start with expecting has the start of a parentheses. Then, personally, in my language, I like the idea that you could say something like val x is equal to, 5 plus 6 or something like this on multiple lines. I like the idea that you can split parentheses on multiple lines without really caring. So what I'm going to do is I'm going to say parser.skip new line here at right after the opening parentheses. And then I'll make the expression that goes inside. And then again, I'm going to skip the new line after so that you can have exactly what we saw before. And then we obviously want to guarantee that there's a closing parentheses. Then we can just make an instance of this and return it. So I would say, if you want a less strict language, right, it's really up to how you sort of do it, right? Because you have a lot of choices for when you skip new lines. If you actually want a language where you need semicolons, then you could sort of your lexer could just completely ignore new lines entirely if you wanted. Personally, I think that languages that have optional semicolons are kind of the ideal, because then you can put things on the same line if you want to, and you can put semicolons on every line if you want to, but you don't need to, because in my opinion, it's just redundant, because you almost never, in my experience, put multiple statements on the same line. It's sort of like in a switch case, right? In other languages, just to get off topic for a moment, with a switch statement, you have to break every single case. But the thing is, that's to allow you to have fall down behavior so you can fall through to other cases. But that behavior is so rarely used in comparison to the break behavior that it seems really dumb to me when languages make the rare thing the norm. It should be reversed to me. Like, a switch statement, for example, it should be, it breaks by default, but you could use the continue keyword to fall down. Because then you can explicitly say, I want this weird behavior that people never actually use. And then you can still have the behavior, but it's the rare thing that needs a keyword, and it's the normal thing that is more concise. And I think that's similar with the semicolons. Because almost every time, every single line of a file is just going to be a single statement. So why should I put 100 semicolons in when I have new lines that function exactly the same? And that's why, personally, in my language, I'm going to do sort of what Kotlin and JavaScript do, which is you can use semicolons, but you don't need to. And the issue with that is I then have to manage when new lines actually don't count as semicolons. But I think that's a fair trade-off. You just have to be clever in your design of when you skip them so that you don't break anything. And so that it's actually flexible. So for example, I'm not allowing something like this to make sense, but I am allowing something like this to make sense. But there is one operator that I will make this exception for, and that's the dot operator, because when you write in a declarative style, you might do something like this, array to sort. You could sort your array, and then you could reverse your array, and then you could do something else. And people like to do this sort of style, which would require me to skip the new line before the period. So when we get to those operators, I'm going to be allowing that because that's what people use, and it makes it more readable. But other operators, I'm not going to be doing that. At least not yet. If people complain, then maybe I will in the future as a language designer. But okay. Hopefully you enjoyed that little rant, I guess. But our primary expression should be all set. We also have our additive, exponential, multiplicative. So let's just start by trying to build it. Make sure it builds correctly, and that's a good start. Nice, and the previous thing still works. So now let me open up our file.c, and let's add something more complicated, like let's say a multi-line string with a string template in it. So we could do something like this. This is a string. This is a string. Second line, which is technically the third token. And then we could do something like, well, we have exponential expressions, right? 2 to the 3 to the 4. Plus 9. Hypothetically, I think this should work. Okay, let's take a look. Nice. Let's take a look at our... Let's start with the tokens, obviously. So we have a 5 plus 6i from before. That's fine. New line. Good. We have our first string token, which is the beginning of the multi-line string with a new line. Good. This is a string, new line. Second line, new line. So actually, the new lines are going to be a part of the string, which is good for multi-line strings, because that's actually what you want. You want the new line to be a part of it, which is good. Then we have a string end of file. That's actually probably not desirable. I think that's an accident. That's not supposed to... Why did that happen? Interesting. And then we have 2 to the power of 3 to the power of 4 plus 9. New line. And then end of the string. So I will have to actually figure that out, because I don't think that's supposed to be there, but it seems like it actually would have parsed correctly. So we have our first additive expression, which is an ended statement because it was ended with a new line. Then we have another ended statement, which is a string literal. And the string has a bunch of components, all of its parts. The first one is that first token, then this is a string, then this is a line. We have that weird end of file that we shouldn't have. We'll have to worry about that in a moment. Then we have the expression, just a literal additive expression node in here, because we're adding 9 to the result of the exponential expression, which is 2 to the power of the result of this exponential expression, 3 to the power of 4. So other than this end of file, which is an issue with our lexer, it seems like it's all working. Vim test. So for some reason there's an end of file. Oh, I see the issue. So what we're doing is when we're doing string interpolation or string templates, we make a token. We always make a string token before we continue. But the thing is, this string token is actually, it has an empty string because there's nothing there, and the empty string is being displayed as end of file. So that's what's happening. So we'll have to go back in and fix that. I'll probably quickly make a fix and then just show you guys. But quickly, let's try a non-multi-line string to see what happens. Something like this, right? It should be x is equal to 5. What's something more? Let's say 5 mod 2I, you know, so that we just know that this is working. You'll notice I put a lot of 5s everywhere. Let's say 43 mod this, and then let's put something after minus equals this in terms of I, like just something, right? Doesn't really matter what it is, I just want to test. And in terms of our tokens, we have a string x is equal to, followed by a literal new line, which is actually good, that's what we want. 43 mod 2I new line. In terms of I, the rest of the string, then a new line. So that's our multi-line string there. And then we have another ended statement, which is a string literal, which has our first string followed by x. It's x equals this multiplicative expression, which is 43 mod 2I. And then another string s in terms. It got rid of all the new lines, which is perfect. So it seems the only issue is that end of file one I mentioned. Let me go quickly design a solution for that, and then I will be right back. All right. So I think I've come up with a solution. Which of these? Oh, I'm in the wrong one. Okay. Let's go up into our... Well, actually, the first thing we need to modify is our source line. So essentially, all we have to check is if the string that we've taken so far is empty, then we don't make a new token, right? So what I'm going to do for clarity's sake, because we do have this new string method as part of our source line, but it feels kind of wrong to reference that, especially because we'd have to pass in the line's own position. So let's just make a simple field to sort of do that for us. And we can just call this taken string, and it's a field, so it needs a getter, and we'll just simply return new string at the position that we already have. And so even though it's called new string, it doesn't actually really modify anything, so we don't have to worry about it. We're not really using it as we intended to use it, but it sort of works out exactly the same way, since it's just a substring line anyway. Now we can go into our lexer, and you'll notice if I search for new token dot type dot string. So we have one here, but you'll notice right before we make this token, there is a file.take, which means it's never going to be empty from here. So if we go to the next one, similar thing, there's a file.take here on line 197. Wow, that's a big file. And we go down here, same thing. But we have these in the small and large string templates. Here are where it hypothetically could be empty. So for both of these, I think all we have to do is add an if check if file.line.the taken string is not empty. Then we make a new token. And we can, I guess I can actually just yank this line. And so we just add a safety guard so that if there is nothing to take, we don't actually make the new token because we don't need to. Okay, and there's probably other ways we could have managed this, but I think this is reasonable and it makes sense in terms of if you're reading it, you know why. So let's try to do the same thing, and let's see if it ends up different. Because I actually haven't tested it. So if we go back to the original, you'll see the end of file happens right after the second line. And looking in our list, I don't see more than one end of file, which is good. And after our second line, we no longer have that end of file because it doesn't need to be there. And technically, it wouldn't have even broken anything if it was there, because once we actually go like make nodes, well, once we actually like transpile it to get the value of the string, we could have just like added a thing. Well, this string, well, what we're actually probably going to end up doing, sorry to just like keep derailing this, we're probably just going to say, if you have a string followed by another string, just like append all the tokens that are in its inside, right? So we can just append all those characters. So that end of file one, it only displays as end of file, but it's actually an empty string. It wouldn't have actually changed anything. But this way, we're just making it more, you know, we're improving the structure of our AST. We're removing junk, and we're cleaning up this output as well. So I think it's worth having done. But okay, I think that's really good. I don't think I guess we haven't done characters yet. It's probably worth just testing all the other ones. We also have parentheses expressions, don't we? So what I could do is something like this. Character, and let's try new line character in here. And primary keywords, so like true. We don't have other operators, so I'll just say true minus false, which isn't currently going to mean anything, but that's fine. See if there's any problems. Okay, well, that's certainly a problem. Unrecognized symbol, parentheses. That's a lexing failure, which means we have to go into our token class, and we have to add it as a punctuator. So yeah, it looks like we never added that as a punctuator. So we need open parentheses here, and we need a closing parentheses. And make sure you split them up, because again, remember, each of these strings is considered one punctuator. So if you had this, that would be considered one thing, and they'd have to always be paired up. But we don't want that. Are there any other symbols we need to add here? I don't think so. We have our true and false down there as well. Let's try again. And that's also a good example of why it's nice to know that this is a lexing failure, because it tells you exactly, you know where to look now as a developer of this language. Oh, it's a lexing failure, so let's look at our lexer. And unrecognized symbol, well, what keeps track of all the symbols in our lexer? Well, it's the tokens. This is where we keep track of all of our symbols. So if there's an unrecognized symbol, we can just come here and take a look. And so that's part of the reason I went through the effort of making this, what did we call it? Like stage verb or whatever. But okay, let's look at our tokens. They look totally fine. We have a bunch of ended statements, which is good. Here's the previous string we made, and then ended statement, which is a parentheses expression, character literal, character containing a new line. And then lastly, additive expression, which is primary. You'll notice it detects that it's a keyword. It becomes a primary keyword, true and false. So I would say that's probably going to be it for this episode. It feels kind of shorter, but we didn't really have too much to do. We just had to finish sort of our nodes. So I hope that you guys enjoyed this. I hope you enjoyed a bit of the debugging and the fixing that we've done. It's always nice to sort of just, you know, fix things that don't make sense. And yeah, in the next episode, we'll either try and expand our grammar so we add more stuff, or maybe we will start work on our type verification. I'm not sure yet, because I haven't completely designed the type verification. So if we're working on that next, it might take a few more days between this episode and the next, just as a heads up, because I'm going to obviously need time in my real life to actually code that before we make it, before we make an episode, because it's bad enough when I try and live code during this. I wouldn't want to live design during this, because that would just make this episode like, I don't know, 2, 3, 4 hours. And maybe some of you would be interested in something like that as a live stream, but I don't know. Let me know if you'd be interested in that. I don't know, that could be kind of fun. But that would actually be super useful, not gonna lie. Just having people over your shoulder, backseat coding, but it could also get annoying. So, I don't know. You guys let me know. I'll see you in the next episode.